Okay, let us continue with our tutorial. So basically, what I've just described to you in the last lesson is that when we're dealing with an absolute value, it has two different kinds of values. It can either be a positive value or it can either be a negative value. I'll explain to you how we eliminate the parts of an equation we don't want, or the parts of an equation of a straight line we don't want, through using our conditions. And I've also explained to you that you must always put your 2 points on either side, because it shows that you know what you're doing and the absolute value function is symmetrical. So we're going to call this example 1. Let's move into example 2. And things start getting a little bit challenging from this point forward. And we'll sketch a graph called y equals negative a half x. So, what are our steps? Firstly, we must say y equals negative a half x if, that's important, let's keep colors, if x is greater than or equal to 0, because x can only be positive if x is greater than or equal to 0. 0 is considered a positive number, which is why we include it. But also, let's just deal with this negative a half quickly. This is not part of the x value. It's rather just multiplied to the x value. We don't actually know what the x value is. Then, let's deal with our second equation, because we know we must have one. Y equals negative 1 over 2 of negative x. So an easy way to say that is just simply x over 2. The condition for that is if x is less than 0, and we don't include the equal to, because 0 can never be classified as a negative number. It is always considered positive. Cool. So now we have our two different equations, which will massively help us in formulating our absolute value graph. So we're just going to do a simple graph. Oh, make sure to always write your y's and x's, okay? Okay, now we're going to do this graph. And we're going to start with the first equation, which is positive. Okay, so this has a negative gradient. I think we understand that. But it is definitely going in a positive direction. Oh no, I'm sorry. This has the negative gradient, so it's definitely going to be looking something like this. And this has the positive gradient, so it's definitely going to be looking like something like this. The reason why I know the graph looks like this and it's not oriented upwards, such as the one above, is because we have a negative value in front of the half. And when we have a negative value in front of the half, the shape of the graph looks like this. Oh, sorry. Whereas if 0 is less than a, or I think a better way to write that is like this, the shape will look like that. What is a, you may ask? A is always the coefficient of the absolute value of x. So in this case, it's here. In our previous example, it was definitely positive 1. We can assume positive 1. It will definitely tell us if it wants a negative 1. Okay, cool. So I expect my graph to look somewhat like this. This should be, at this point, really easy to identify. Then we also get something called the salient points. And these salient points are always 0, 0 at this point in time. So your salient points are where both your straight lines meet. In tests and exams, they do ask you where your salient point is, and it is your responsibility to know where it is. Okay, cool. So we're finally dealing with this graph over here. Okay, so let's do with y equals negative a half x. So you can just basically substitute points into this. As I said, don't do the hard things. Like, why are you doing the hard things, girl? Just don't do that. You're gonna get negative a half. So sorry, everyone. It needs to be a negative value. No. I'm lying to you. Sorry, guys. I kind of switched up the colors. Okay, what was the mistake I made and why shouldn't you make it in the exam? Because we're dealing with a negative gradient, but a negative gradient is always going to go this way because, as I explained, when we say y equals negative x, the line usually looks something like that. However, when we do have a positive gradient, the gradient always looks like that. And so therefore, your positive gradient is actually going to go this way. And so therefore, when I say y is equal to negative a half, and y equals 1, this is the correct assumption for me to make because 1 is, firstly, it's positive. You can see that here. So it is positive. 1 is positive. And the condition is that x must be positive. And only when I'm dealing with this equation, which I'll deal with in a second, will I use an input a negative value for x. Okay, this is great. So we're understanding what's going on. Let me just change the colors here so we understand what's going on. Okay, so, and then we can do the point. So when x is 1, y is equal to negative a half. Okay. The second equation we're dealing with is when y is equal to x over 2. Okay. So don't make it hard for yourself. Just always input the negative 1. The reason why it's negative is because we're exclusively dealing with this part of the x-axis. So all your x values are negative. That makes sense because 0 must be greater than all your x values in this circumstance. So then you'd say negative 1 over 2. And then you'd get y equals negative 1 over 2. Then you'd put that on your graph and you'd say when x is negative 1, we get negative a half. Then always remember to just write in your equation. So we're looking at y equals negative a half x, and we're also looking at y equals x over 2. And if they do want the salient point, which I explained that examiners do want it nowadays, then you just say 0, 0. It's always nice to do your salient point in a different color, just so it is nice and bright for your examiner to see.